So let's take these pure substances and look at the different categories. We talked about this earlier. We can divide them into elements and compounds. The elements we can divide into two categories, atomic or molecular. Atomic elements are going to have, as their smallest particle, individual atoms. Some elements exist in the molecular form. Oxygen gas is one of these. You don't have individual oxygen atoms floating around in the air. They go around in pairs, covalently bonded together. And then for the compounds, we can divide these into molecular compounds or ionic compounds based on the types of bonds that they have. So a molecular compound is going to be composed of molecules, and those molecules are atoms that are covalently bonded together. An ionic compound is going to be composed of ions, and they're bonded together by ionic bonds. So most elements are atomic elements. There are a few that exist as molecules. There are 7 that we are going to need to memorize: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These are called diatomic elements. Diatomic meaning 2 atoms. So they form molecules that have 2 atoms. Phosphorus and sulfur are polyatomic elements. And they form different types of molecules. There's red sulfur, and there's white sulfur, and there's yellow sulfur. And it depends on how the atoms are covalently bonded together. But phosphorus is often found as a molecule of 4 phosphorus atoms, and sulfur as a molecule of 8 sulfur atoms. So this is a periodic table showing these molecular elements. The ones in yellow are the ones you really need to memorize. And there's different ways of memorizing those. One is BVINCIHOF. That was somebody's attempt to make a word out of the element symbols. Another one is a mnemonic, a sentence. Horses need oats for clear brown eyes. Horses need oats for clear brown eyes. Yeah, so that's a little bit of a stretch at the end.
What are the numbers for the polyatomic element?
P4 and S8, but I don't expect you to remember those. So these are the first letters of the element symbols, right? You got that? So that's another way. There are 7 of them, and I think it's kind of neat that if you start with number 7 on the periodic table and make a 7, those are 6 of them right there. And then hydrogen's over here. What we're going to find out is that hydrogen likes to be an exception to everything. He's like the baby brother of the family. Okay, so in my family of 6 children, there is a baby brother, right? His name is Andrew. He just turned 7, coincidentally. Andrew gets away with stuff that the older kids would never have gotten away with. Mostly because we're just old and tired and realize it doesn't matter that much anymore. It just, he'll be fine. So we let him get away with stuff. And we know we're doing it, but he's just so dang cute. So that's how I see hydrogen. Hydrogen's a lot like my son, Andrew. But hydrogen's going to be over here because he's not going to be with these guys because that would be too nice. But there's a 7 there. And so these guys, NOF, ClBrI, plus hydrogen. What's important here is that anytime you have one of these as an element, it's a diatomic molecule. And so the formula is going to be F2, or I2, or H2. It's not going to be an individual atom. Okay, so that's something we have to remember. So that was molecular elements. Molecular compounds usually contain 2 or more covalently bonded nonmetals. It's the nonmetals that are going to share the electrons. And the basic units in these molecular compounds are molecules, discrete molecules. So water has H2O molecules, 2 hydrogens, 1 oxygen. All the molecules are the same. Dry ice is composed of CO2 molecules, 1 carbon, 2 oxygens. Propane, used frequently in grills, C3H8, a molecular compound. And we can identify molecular compounds by looking at the elements in them. So carbon and hydrogen, you find those on the periodic table, and they are nonmetals, right? Carbon is to the right of that stair-step line. Where's hydrogen? He's to the left, hanging out with the metals. What's he doing over there? He's being the baby brother of the element family. He doesn't really belong over there, but sometimes he does belong over there. So we see him over there a lot. Is hydrogen a metal? No. I mean, most people would recognize that hydrogen is not a metal. So that's one that you can just remember. But you look at the elements that are in the compound. Non-metal, non-metal. It's going to be a molecular compound. Ionic compounds, you're going to have ions. You're going to have cations, positively charged, and anions, negatively charged. And that's what forms the ionic bond that holds them together. The basic unit of an ionic compound is not a molecule. It's a formula unit. It's the smallest electrically neutral collection of ions. So if we think about table salt, sodium chloride. So this is the formula unit. It's the combination that gives us a neutral charge with the lowest ratio. So it's a little bit like an empirical formula. For every 1 sodium ion, there's going to be 1 chlorine ion. And so that's why the formula is NaCl. If we had perhaps barium, what charge does a barium ion have? +2, because it's in group 2 of the periodic table. That's how we know. If we had barium and chloride, and we just had 1 of each, it wouldn't be electrically neutral, would it? There must be 2 chloride ions for every 1 barium ion. And so when we write the formula for this, we're going to write BaCl2. It's the lowest combination that will have no charge overall. So here's an illustration of an ionic compound, sodium chloride again. So we don't talk about molecules for ionic compounds because it's chloride, sodium, and it just repeats that way all throughout the crystal. If the crystal's bigger, it just keeps repeating. There's no individual particles. The ions are bonded together, but they're bonded on all sides. And so that's why we talk about a formula unit, because if you're going to, insist on molecules, well, then the whole salt crystal is going to be 1 molecule because they're all bonded together. In a molecular compound, you have discrete molecules. So this is propane. And in the gas state, we see there's a lot of space. My pointer just there, come? No? Fine. Look, there's lots of space, right? And there's individual molecules. When you condense propane into a liquid, you still have those individual molecules, they stay intact. If you freeze a solid, the molecules are not held to each other by covalent bonds, they're held together by something else. So molecules are held together by covalent bonds, and you have these discrete units. In ionic compounds, the whole thing is basically 1 molecule. Does that make sense? Polyatomic ions. So I made you memorize some of these, didn't I? There are many ionic compounds that have ions that are composed of covalently bonded atoms, but they have an overall charge. So the compound sodium nitrate has sodium ions and nitrate ions. A polyatomic ion is an ion that has more than 1 atom in it. It's an ion because it has a charge. So what nitrate is, what's up with my pointer? What nitrate is 3 oxygen atoms one nitrogen atom. They're covalently bonded together by sharing electrons. And then overall, there's one extra electron. So the whole unit has a -1 charge. And that's what the polyatomic ions are. We'll learn a lot more about them later. At this point, we should be able to classify substances. So each of these, we're asked, is it an atomic element, a molecular compound, or an ionic compound? So fluorine. It's an element. What kind? Molecular or atomic? Is fluorine one of the 7 diatomics? Yes, it is. Horses need oats for clear brown eyes. Fluorine is found as F2 in nature. And so this is a molecular element. How about N2O? Molecular compound. We can tell it's a compound because there's 2 different elements. So it's got to be a compound. And we identify it as molecular because we look at what kind of elements are nitrogen and oxygen. They're both nonmetals. So this is a molecular compound. I'm going to call this MC. Silver. It's an element. So is it molecular or atomic? It's atomic. It's not one of the 7. And phosphorus and sulfur would also be in there as polyatomics. I won't intentionally trick you with that on a test. So this is an atomic element. How about K2O? It's an ionic compound. So this is IC. Potassium is a metal. Oxygen's a nonmetal. So this is going to be ionic. How about Fe2O3? It's another ionic compound. Any questions?
So you said salt could be classified as all one molecule?
Yeah, there's not a discrete molecule. If you were trying to think of it in terms of a molecule, you'd have to say the whole piece is one molecule. And then every molecule would have a different number of atoms, and that kind of defeats the idea of a molecule.
And that other one you were comparing it to, that wouldn't be considered all one molecule because it was a...
The propane?
Yeah. I'm sorry, because it was an ionic bond.
So in this one?
Oh, I'm sorry, covalent.
So this one has covalent bonds. There's carbons and hydrogens, and they're bonded together by sharing electrons. And in between the individual molecule, there are no covalent or ionic bonds. In an ionic compound, you have individual ions that are held in this 3-dimensional lattice by ionic bonds.
No matter the temperature?
Yeah, no matter the temperature, until you get to the point where you vaporize it, which is at an extremely high temperature. And at that point, you're going to have individual ions in the gas state. You're not going to ever have molecules.
So with the molecular compound, it would change the state with temperature easy?
Molecular compounds tend to melt and boil at lower temperatures because the forces that hold their particles together are weaker than ionic bonds. But when you get a molecular compound in the gas state, you have individual molecules. When you get an ionic compound in the gas state, you have individual ions. And there are never discrete molecules. So we write the formula for sodium chloride as NaCl, but there is no NaCl molecule. It's just the ratio. A sodium chloride crystal contains 1 sodium for each chloride. And it just depends on how big the crystal is, how many there are. Does that help?
Yeah.
You had a question?
Is mercury not considered diatomic molecule?
Mercury is not a diatomic molecule. It forms a polyatomic ion, but it's not diatomic as an element. Any other questions?